All right, we're recording. We're rolling. So let's get right into it. We're working on the second half of chapter 6 today. And we left off last week getting into yield to maturity for bonds. Now, just a quick recap. There are multiple bond markets. You have municipal bonds, corporate bonds, um, treasury bonds, and then other bonds. And most all of them are rated by credit agencies. And to review on the ratings, let me just pull up the slide that we were going over the other day here. Like this is a common rating scheme that you'll see. So Moody's, AAA, then you have BAA and BA. So they rate it based on how high the risk would be, and that's all based on the company's financial statements and financial position, not only within the industry, but within the bond market as well. So, just wanted to say congratulations to women's soccer, knocking it out of the park. I hope that everybody roots for our teams. Actually, on that note, I believe it's November 16th, I'm going to be in Alma to see the football game, the Lions versus Scots there. So I'll have my FU hat on, and we'll be rooting for you guys for the win. So if anybody's on the team, look out for me in the stands. I'll be the crazy guy, rooting for you guys with the FU hat on. All right, moving on. So we did a couple of problems that had to do with, finding the desired rate of return that companies would want based on a set of parameters, and those parameters are usually the maturity value, which in most of our cases will be at $1,000 per bond. The coupon rate, which is the amount you get paid every payment period, which is usually every 6 months. Some of the problems we'll get into will be every year. So, that's kind of the amount that you're making for loaning the company or the municipality money. So a bond in general is a loan. The bond creator is accepting money in repayment. They're going to pay you a certain amount, which is your coupon rate per payment period through the maturity of the bond, which then you get back the face value in the end. So there's lots of things that we can figure out based on those parameters, including if we don't want to hang on the bond until the end of the maturity, how much can we get for that now if we're to place it on the secondary bond market? Because secondary bond markets are, filled with opportunities for financial managers to increase the bottom line of the company. So it depends on your financial position and if these secondary bond offerings are attractive to your particular need. So let's get right into the rest of the chapter 6 slides here, and then we'll cap off with some end of the chapter problems, so you can see how the previous chapters are going to be building into some of the problems here in the second half, chapter 6. So this is a bit of a recap here. Yield to maturity is the average rate of return earned on a bond if it is held to maturity. So that's kind of what I'm getting at. A lot of entities do not hold on to bonds until maturity. They try to make receive money now so they can invest it in a more attractive offering, based on some of the stuff we just went over. All right. So another example here, and we'll go through the handwritten formula, and then we'll always have an Excel lesson. So that's what I want to teach you guys how to use is Excel, because it's widely available in businesses and in academia and nonprofits, and you can even get your own version of it or subscribe to Microsoft 360 to get the most updated version all the time, because they just do over-the-air updates now for a subscription, and I've been doing that for multiple years. But also using Excel can help you get to the answer quicker, in my opinion. But some people that do calculations well and use the financial calculators, if they've brought themselves up that way in financial calculation, then it's easier for them. And I know a few of you have been doing that, and that's okay, because understanding the math is one thing, understanding the Excel commands are a completely different thing. But it gets you to the same answer. All right, suppose you were offered a 10-year, 8% coupon, $1,000 par value bond at a price of $875. So you're purchasing this in the secondary bond market. So that means the original bond issuer issued the bond, somebody got rid of it, and now it's on the secondary bond market for this much. Interest from this bond is paid semi-annually. This will be important because it tells you how many coupon payments you get in a year. And you'll have to, manipulate your formula as a result. So what is the bond's yield to maturity? Again, this is the value of the bond. And we get into, we went over the formula last week, and I'll just bring that up real quick. Sorry, I'm just looking through here. All right, here. So this is your formula, and this was the notation. The required rate of return is going to be RD. INT is your dollars interest paid each year. So this is a dollar amount, not a rate. N is the years, and M is your maturity. So here's another look at it. And then this is a calculation on this problem. So sorry for the moving around. I'm just trying to, you guys can pull up the PowerPoint on your own. And this fits into what we're doing with Excel. Yield to maturity is the average annual rate. I over Y is your desired rate of return. And this is what firms look for, or people that want to make a certain return based on your maturity value and coupon rate. So now if you have a semi-annual payment, you're going to break everything down. You're going to multiply your N by 2 and divide your payment by 2. But in the end, so if you factor it by 2, your I over Y is going to be, your desired rate is going to be a 6-month rate. And we always want to answer our questions in annual rates. So we're going to have to multiply it by 2 to get that annual rate. So I'll in the end of the chapter questions, I'll show you just, you're going to want to have a cell that's right next to your calculation saying this is your annual rate versus your 6-month rate. And it's just multiplying it by 2. Just remember to do that in semi-annual payment questions. So now moving on to yield to call. That's saying, all right, I'm holding on to my bond, but I don't want to hold it to maturity. So say I want to get rid of it after a certain amount of payment periods, how much is my desired rate of return, and how much money am I going to get from that? So you're able to calculate these in between numbers instead of your full maturity numbers, which is widely used by all financial managers at this point, because you can think of their portfolio as this giant um, engagement in buying these different secondary bonds in addition to other financial mechanisms that all go towards increasing the bottom line in your financial and investing activities. So yield to call is the average rate of return earned on a bond if it is held until the first call date. And C is your notation here, number of interest periods to the first call date. So a lot of bonds come with designated first call dates, and there are some that do not. So you're not anchored in for a specific amount of time, but a lot of them do have, you have to hold on to it for this long. Suppose that you had a bond that could be called in 4 years at a price of $1,080. So this is saying, okay, oh, this is a typo right here. This is supposed to be 1080, not 1800. Let's see if we can. Yeah, let's switch that. All right. And we got the vacuum. Hello. No, thank you. Yep, have a good night. Every time. And I tell her that Tuesdays, not, but it's neither here nor there. It's funny. All right, back to the lecture here. Suppose that a bond can be called in 4 years at a price of 1080, and this is on these parameters here. So yield to call with these numbers, always going to have, if it's on the market for a price of 875, remember that's how much you would be spending, so it's always negative. And then it said semi-annually, so we break it down into, if the call date is in 4 years, then we do n times 2, which is 4 times 2 is equal to 8. Payment, again, remember, is your coupon rate times your maturity value divided by 2, because we are in semi-annual. So if we have an 8% coupon rate times 1,000, that's $80 divided by 2 is 40. So your payment is 40. Future value will be your maturity value. Oh, whoops. We're in your yield to call now. So now the bond market sets a price saying, okay, in 4 years, you can call in for a call price of 1080. So that means your future value now isn't your maturity value, it's your call value, which is set by the bond market. And it'll be stated when you engage in purchasing the bond. So you'll know what this price is 4 years previous. So we're saying then, okay, what's my desired, or what's my rate of return based on these parameters? So if we're holding a $1,000 maturity value bond for 4 years, and we're getting semi-annual payments of 40. So we're saying, okay, so 4 years times, or 4 years turns into 8 payment periods. So 8 payments of 40 is $320. add it on to your 875. So this is kind of how you would think as a financial manager. If I spent 875 and I'm going to make 320 for holding on to it for 4 years, and then I get 1080 when I call it in. So that's the kind of thought process you want to have. What's my rate based on those numbers? So doing the math here, we'll do a couple of these questions in Excel later on. 6.87%, but that's your 6-month rate, and you want to multiply that by 2 to get your yield to call annual rate of 13.74. So always, if it's a semi-annual, you're going to want to multiply your rates by 2 in the end. And that is not the case if it's an annual payment. All right, moving on. So I kind of mentioned this last period, but we're talking about coupon rates versus rate of return. And technically, we'll just run through this. If your rate of return is equal to your coupon rate, then your maturity value will sell at par, meaning you're always going to get the face value if your desired rate of return is the coupon rate. Additionally, if your rate of return is greater than your coupon rate, you're going to sell the value of the bond at maturity sells at a discount. So that's saying that, and we'll get up, there'll be a visual graph in this presentation later, but technically the thing to remember now is if your rate of return is greater than your coupon rate, the bond's going to sell at a discount. And then if your rate of return is less than the coupon rate, the bond's going to sell at a premium. So just remember those factors, and I'll show you how that looks in a visual. I think that's the last slide or close to it. But always remember, greater than is sells at a discount, and less than is sells at a premium. So whenever the going rate of interest equals the coupon rate, a bond will sell at its par value. An increase in the interest rates will cause the price of the outstanding bond to fall. So that's saying rate is greater than your coupon rate. So interest rates will cause the price of the outstanding bond to fall. Sells at a discount. So that's a way to put it into words. Decrease in interest rates will cause the price to rise. The market value of a bond will always approach its par value as maturity date approaches, provided the firm does not go bankrupt. So remember, that's saying this all depends on the financial position, and including municipalities. Detroit went bankrupt, and a lot of those creditors had to settle on something that was less than their original agreements. All right, here's a visual on that, and there's another visual towards the end. But so this is saying the vertical axis here is bond value, and the horizontal is time. So time path of the bond when your desired rate is 8%, which is less than your coupon rate. The par value is going to be greater than, the market price is going to be greater than your par value. So par value and maturity value and face value are the same thing. So just remember that. They're all synonymous in this case, so don't think I'm talking about something different. So on this, the secondary bond market, this will sell for more than the face value. This is an example of it being equal, the rate being equal to the coupon rate. And then, of course, if your desired rate is greater than your coupon rate, it's going to sell for a decreased, an amount that's below par value. And this is all because that you're like for this, in this case, you're going to be making more money in the end than you are holding it to maturity. So it's kind of it's an art. So the more you are engaged in purchasing, the more you'll realize that, okay, so I'm standing to make 12% by holding this to maturity. Is that good enough for me right now, or do I want to call it in early and get into something else? So it's all based on what's available on the market, and if what's available on the market compared to what you already are holding can be liquidated to invest in something that will increase your bottom line. Any questions on any of this so far? This getting into yield to call kind of is yeah, go ahead. All right, let's continue. So calculating the bond yield, it's easier than it looks. This is kind of building on, I believe that was chapter 4. But we want to take our end values, subtract our beginning values, and divide by our beginning values. And this is always, okay, so over time, the market price fluctuates while the maturity value stays the same. And that's unless otherwise stated in a call situation. And we'll get into some examples here. So interest, remember, is the dollar amount, and then the value of the bond in the beginning, the value of the bond in the end. So that's how you want to read this formula. Interest rate price risk, the risk of changes in a bond, prices to which investors are exposed during the changing interest rates. So yeah, I'll show you how to look at the treasury bond rates, and most, first you have your Federal Reserve rate, and then you get to your treasury rates. And both of those define your risk, the treasury rate defines the risk-free rate, which helps define the discount rate from the Fed, which then helps corporate bonds, municipal bonds, other bonds to form their rates on top of those. So, and this all has to do with the risks of adding more value on top of those risk-free rates. Interest rate reinvestment rate risk. So that's again what I'm trying to say. Is there a reason why I should call this in now to liquidate it and then invest in something else that can increase my bottom line? And that varies because cash flows have to be reinvested at current or perhaps lower market rates. So that's why it's good to watch the movement of the rates daily and the available offerings on the secondary bond markets. All right, so this is another visualization. The difference between a 1-year bond and a 15-year bond. So the more time there is, the more risk there will be. And then this is kind of going to show these are the rates here. And this is a coupon rate of 10% for a $1,000 maturity value bond. So if we're saying that the desired rate is less than, so imagine this is the desired rate, and you go up to the 15-year bond here. So the desired rate of return is less than your coupon rate. Your bond is going to sell at a premium on the secondary market. If your desired rate is greater than your coupon rate, your bond is going to sell at a discount on the secondary bond. So that means that you have to account for time and value over time. So that's the that's the catch, and you'll get used to it as you continue to do this later on, either in your academic careers or on the job. And here are some. This is just some data over time. 2013, 2014, 2015, all the way up to the end of 2017, reflecting total yields on bonds. I believe this is average based on market prices in the secondary bond markets. So yeah, in years where capital gains are negative or low, those are years that you know that a lot of the money that's out there is being invested into the market. So let's go right into some end of the chapter questions. I was having trouble loading Cengage earlier, so let's see if they're popping up now, and if not, I've pulled up some of the questions on Chegg here. So we'll just see if this loads up right away, because usually it'll pop up right away, and if it doesn't, then I'll pull up the Chegg questions here. Yeah, like this is what I've been getting all day, so I haven't been able to actually get to the questions in the digital book here, but luckily there are other options, and we can start by looking at what I've assigned for tonight. Already in week 9. It's going fast. So 10, 14, 17, and 19. So let's do questions around those. Oops. All right, so then we'll pull up. So let's do. So yeah, this is another way to find the problems here, which is good. So, all right, so 10. Let's do number 11. All right, and this is the same question that's in the 5th edition, number 11, into the chapter, and it's the same in 6, the 6th edition. So all good there. Now, let's see here, number 11. Severance company bond has 4 years remaining to maturity. Interest is paid semi-annually. Bonds have a $1,000 par value, and the coupon interest rate is 9%. Compute the yield to maturity for the bonds if the market price is $851 or $1105. So now we're computing the desired rate of return. So that's what the yield means. Compute the yield. So that means we're going to use our regular build up here. And future value. So let's plug in the numbers that we know. $1,000 par, so that's your future value. Payment is going to be 0 in all of these. Excuse me. Payment itself is going to be, there's 3 things you need to know. What's your par value, what's your coupon rate, and is it semi-annual? So it is semi-annual. So equals par value times the coupon rate, which is 9%. And then you divide that by 2 because it is semi-annual. Present value, so we'll start with A, and that's negative 851. This is what we're looking for. And company has 4 years remaining to maturity, and it's semi-annual, so that's equal to 4 times 2. So equals rate, double click, asking in per, comma, payment, comma, present value, comma, future value, comma, type. Hit enter, 7%, and always, you can pump it over once for these guys. But again, that's your 6 month, and they want to know what the yield to maturity is, so that's always going to be an annual rate. So you just want to do equals this times 2, and then percent. All right, now for B, we're going to have a lot of the same stuff. So equals 4 times 2. Looking for that. So if the price is 1105, that's negative 105. Payment is going to be the same. 1,000 times 0.09 divided by 2. That's going to be that, and that's going to be that again. So equals rate and per payment, present value, future value. And then again, you got to multiply that by 2 to get your yield maturity. Percent, pump it over. Now this is saying, okay, coupon rate is 9%. So if my rate of return is less than my coupon rate, it's going to sell for a premium. If my rate of return 14% is greater than the coupon rate of 9%, it's going to sell on the market for a discount. All right. Moving on. Let's do number 12. Decor Interiors has an outstanding bond that was issued 20 years ago. The bond has $1,000 maturity value and a 5.5% coupon rate of interest. Interest is paid semi-annually. Bond, which matures in 5 years, is currently selling for $10.22. What is the bond's yield to maturity? So we can just copy. This one is, all right, the bond matures in 5 years, and it is semi-annual. So we go equals 5 times 2. That's what we're looking for. Present value is what it's currently selling for, so 1022. Payment is equal to par value times coupon rate divided by 2 because semi-annual. Future value is 1,000. Oops. Rate per payment payment, present value, future value. 2%. Again, this is our 6-month yield. Always bump these out. This is our annual yield here. So 5%. There's a little bit of work, but it all builds up to this. So, you know, just send me an email if you have trouble understanding it. All right, so let's go to number 13. Four years ago, Messy House Painting issued a 20-year bond with a $1,000 maturity value, a 4% coupon rate of interest. Interest is paid semi-annually. The bond is currently selling for $714. What is the bond's yield to maturity? B, if the bond can be called in 3 years for a redemption price of $10.16, what is the bond's yield to call? All right, so we have a yield, maturity in A, and then a yield to call in B. So let's start here with A. All right, so 20 years ago, a 20-year bond with a maturity value. Bond is currently selling. What is okay? 4 years ago. So okay, so we have a 20-year bond issued 4 years ago. So that means we have to do 20 minus 4 times it by 2 because it's semi-annual. Oops, got to hit equals on front of that. So again, that's what's the length of maturity, how many years ago, to figure out where you are in the holding the bond process. So you can figure out what your actual yield to maturities would be. So present value is 714 to the negative. Payment is equal to par value times the coupon rate, 4%. And then you divide that by 2 because it's semi-annual. 0 and 1,000. All right. Always multiply it by 2 if it's semi-annual to get your annual. Percent. All right, now let's move into the yield to call portion of this. So we have, let's see here. If the bond can be called in 3 years for a redemption price of $10.16, what's the bond's yield to call? So if it can be called in 3 years from right now, we're saying 3 years times 2 because it's semi-annual. We're still looking for the rate. Present value is still negative 714. Payment is going to be the same times 0.04 divided by 2. Payment type. But now the future value changes to 1016. Because that's your call-in value. All right. And payment, present value, future value type. 8%. Pump it out. All right, so your yield to call is 17% because you're shortening the time period and still receiving payments, and you have a maturity value that's higher than the face value because the market deems it that way. All right, let's do a couple more and then we'll call it a night here. So let's try, sorry about that, number 15. All right. Quiver Archery's bond is currently selling for 10.06. Its value 1 year ago was 996. The bond has $1,000 maturity value, coupon rate equals 7%, and it matures in 8 years. Interest paid annually. So that means we don't have to do anything by twos anymore because it's annual. Compute the current yield and capital gains yield the bondholders earn during the year, and B, the bond's maturity, yield to maturity today. All right, so the first one is just going to be some arithmetic, and if we remember, the equation is interest divided by your beginning value. So we'll do one at a time because you want to do your current yield plus your capital gains yield. So the first one is your current yield, which is this, your interest divided by beginning. And what we're saying here is your interest is your coupon rate, 7% times your maturity value. Oops. And then divided by your beginning. So 1 year ago was 996. That's your beginning value. Oops. Oh yeah, it equals. You're doing an equation. And interest. Now your capital gains yield is your ending minus your beginning divided by beginning, which in this case is ending was 10.06. Sorry, I'm starting to see double and stuff. Oops. Sorry about that. So 10.06 minus 996 divided by 996, 1%. And then if you remember, you just add those together. Boom. So that's A. So the current yield and capital gains yield earned during the year altogether is 8%. And then B is going to be, we can use our regular, excuse me. All right, the yield to maturity today. So we have selling 1 year ago, the bond has maturity. It matures in 8 years and is paid annually. So since it's annual payments, N is equal to 8. We are looking for my present value is negative So it's currently selling for that. So that is the current present value, negative 1006. Payment is going to be equal to your coupon rates times par value. There's no semi-annual payment, it's an annual payment. Future value is payment. Equals this time. Oops. That is it. Excuse me. So since that's an annual everything, you don't need to multiply anything by 2 at the end. So yield to maturity right now is 6.9% based on these numbers. Any questions on any of that? All right, let's do one more and then we'll call it a night. So number 18. All right, 1 year ago, Henderson Honey issued 10-year bond for $1,000. The bond's coupon rate of interest is 4%, and the interest is paid annually. If the current value of the bond is $929, what are A, the current yield and capital gains yield, and then B, the yield of maturity. So it's the same as this one up here, pretty much. So interest divided by beginning is going to be equal to so the beginning was 1,000. So your interest is going to be equal to sorry, my mind's just shutting down, so I'm gonna I'm trying here. All right. Let's let me focus on this. Yeah, so the beginning is 1,000, so we have equals 1,000 times coupon rate. Oops, and then you divide that by your beginning, which is 1,000. So we get 4%. Here is your ending minus your beginning divided by your beginning. So that's equal to what is it? 929 minus 1,000 divided by 1,000. So yeah, that's a negative if you start at 1,000 and you go down to 929. That's bad. And then the total is you add those together. So equals plus. So yeah, negative 3.1%. It's not very good. And that is your current yield and capital gains yield together. Copy. All right, moving on. The yield to maturity. All right, so 1 year ago, Henderson Honey issued a 10-year bond. So I just say always just go through the motions here. So 1 year ago, they issued a 10-year bond. That's 10 minus 1. Excuse me. We're looking for the yield. Present value is negative 929 because that's the current value of the bond on the market is 929. payment is going to be, let's see, par value times your coupon rate. Payment type is 0. Future value is equal to 1,000. 5%. There we have it. That should be good enough for you guys to get through the second half of chapter 6. If you haven't done so yet, please do the discussion question assignment, and then I'll post the other one in a little bit. All right, so thank you guys for tuning in, and have a good night. Now I'm gonna just log off here. Let's see.